High level. Good morning. My name is Jiratik. I am from CSSC section. My ID number is 21951A05G2. Today we are going to see computer organization and architecture. My topic is high level language abstraction for reconfigurable computing. One consequence of increasing VLSI system speed and circuit density is growing viability of field programmable gate arrays as platforms for configurable computing systems. RC systems typically consist of an array of configurable computing elements. The computational granularity of these elements ranges from simple gates as subtracted by FPGA lookup tables to complete arithmetic logic units with or without registers. A rich programmable interconnect completes the array. The pros and cons of fine versus coarse-grained reconfiguration have been widely discussed. One, although several projects have investigated and successfully built a system in which is reconfiguration is done within a processor or among processors, we restrict our focus to more common FPGA-based systems. FPGA advantages. Computing with the FPGAs offers many advantages over traditional non von Neumann processors. If the computation supports it, FPGA circuits can be massively parallel and customized to the task, whether this requires task data or pipeline parallelism or a mixture of FPGA circuits also can be specialized in terms of bit resolutions. If a program needs to add a 9-bit value to a 12-bit value, it can be construct a specialized adder for this task rather than wasting circuitry with a standard 32-bit adder. Implementing the program as a circuit data streaming through it eliminates all the logic associated with instruction and addresses decoding. As a result, FPGAs can achieve speed up several orders of magnitude greater than that is traditional non-Neumann processor. One, two, as well as significant reduction in energy consumed as important consideration of for mobile devices as VLSI technologies increase in both density and speed, more internet and opportunities for the technology will arise. Programming limitations. Pro- Programmability provides the most daunting challenge developer face when using RC systems. In a typical design flow, the developer manually partitions an application into two segments: a hardware component that will execute a circuit on the FPGA and a software component that will execute as a program on the host. The developer expresses the hardware component in an hardware description language such as VHDL or Verilog. The software component work as a driver, feeding input data to the FPGA and collecting output data. These are the programming limitations that this time-consuming approach to circuit design is a tedious process because complex algorithms must be expressed in terms of bits, registers, and clock signals. Moreover, because they typically lack circuit design skills and knowledge of hardware description, languages, application programmers tend to find the hardware design paradigms inaccessible. Single assignment C. To overcome these problems, we developed a complete automated completion completion path from algorithmic programming language to an FPGA-based configurable computing system. The high-level language, a variant of C called single assignment C, expresses image processing application at high level. SAC is amenable to efficient compilation into fine-grained parallel hardware systems because it hides the details and intricacies of low-level hardware design. At the same time, the SAC compiler leverages extensive optimizations and code transformations to increase the speed and reduce the size of the resulting circuit. Design challenges. Initially, we hesitated to design a new programming language. Most application developers already trained to use C and C++ are understandably reluctant to learn a new language. Unfortunately, C is incontestable linked to the non-human processor model in which variables corresponded to memory locations and functions in invocation reside on stacks. For example, C let users manipulate pointers to memory and to functions, which does not make sense in a FPGA circuit model. Thus, any attempt to compile C to FPGA configurations will encounter problems that derive purely from the C language, not from the image processing application. At the same time, simply compiling a subset of C to FPGAs might not always be efficient because the disallowed operators will almost certainly be present in any existing C program. If this will then require rewritten reading existing programs for the C subset. For example, say it will be difficult to write efficient code for processing images or other multidimensional arrays in C without pointer manipulation. Thus, developers will need to add new facilities to C to compensate for any disallowed operators. When developers work with both restricted and extended C, they essentially create a new programming language or at least significantly different dialect of C. SAC restrictions, as the name suggests, SAC most important restriction in comparison to C is that the value of any variable can be set only once when the variable is declared. Many functional programming languages use this single assignment restriction, which breaks the non-human equivalence between variables and memory locations. Since variables can be set only once they correspond to values, not addresses, can be assigned directly to wires. SAC also removes the C differencing and address operators, thus eliminating pointers and forbids recursion. To compensate for these restrictions, SAC introduced the two multidimensional arrays, including arrays whose size is known at compile time. More significantly, it is also introduces a new version of the for loop that ex- exploit multidimensional arrays, allowing users to apply a loop body for every element, window, or dimension of an array. A reduction clause at, at the bottom of the loop body neither collects values into a new array or applies a reduction operator to values in produces it produces most of the code translated into FPGA configurations takes the form of these extended loops. To take advantage of an FPGA's ability to create a arbitrarily sized circuits. SSE adds variable bit precisions, integers, and variables bit precision fixed point numbers to see. It also allows any functions, loop, or conditional expression to return multiple values, a significant feature given the signal assignment restrictions. Compiler optimizations. The SSE compiler supports a wide range of optimizations aimed at producing a more efficient hardware execution. Most of these optimizations seek to reduce the circuit size, propagation delay, or input or output requirements. SSE optimizations 5 to 7 include traditional methods such as constant folding operator, strength reduction functions, inlining dead code, elimination, invariant code motion, and common sub-expression elimination. Other optimizations are specific to SSE or adapted from vector and parallel compilers or synthesis tools. This include bit width narrowing, loop unrolling, loop fusion, shift mining, and temporal common sub-expression elimination. Figure 1 shows an example of the SSE code for a convolution with a window of size RC of a fixed array kernel. Over the array image, both the kernel and image arrays will have been declared earlier in the program. The value of conv is declared to be unsigned 8-bit integer, which means that irrespective of the kernel and image arrays element size, that the result of each convolution will be cached to unit its size. This is the SSE program. Other languages SSE differs significantly from the other efforts to map higher level languages to hardware. Handle C programs more closely resemble hardware than SSE programs. The user must explicitly specify both timing and parallelism the occupy and system C extensions work with the class library to create an application at the high level, then gradually migrate certain parts of the code toward a more explicit hardware descriptions. Perhaps the closest language to SSE streams C8, but while SSE encompasses loops and other streams C encompasses streams and processes. SSE has also built on the experience of previous single assignment languages such as C. Thank you.